Good evening, everyone. Welcome to week 8 assignment solving session. Today I'll be discussing solution to week 8 assignment questions and some of the uh, questions related to week 8 lecture materials. So let's start. The first question is an example of cyclosilicate is option A calcium magnesium silicate, B Mg3 OH twice Si4O10, C Zn4 Si2O7 OH dot H2O, or option D B3L twice Si6O18. So there are so many different types of silicates, and one of the type is cyclosilicate, and its formula for is SiO3 n times 2n minus, and from here uh, beryl, which is B3Al2Si6O18. It's an example for cyclosilicate. So here, if we uh, go through the charge for each one, here calcium is in +2, magnesium is in +2. So 2 plus 2 is 4. So this part will be 4 minus. So SiO3 twice 4 minus, and here Mg3 is 2 plus, Mg is 2 plus, OH is -1, and so similarly we can calculate for all the SiO units, and we will see that beryl B3Al2Si6O18 will be having this formula, and uh, in this one uh, Si6O18, uh, this is beryllium is in +2, aluminum is +3. So we will have to calculate the negative charge for this one. It's in total will be +6, and again this also will be +6 because 2 aluminum is there. So 2 into 3 plus will be +6, and 3 into +2 will be +6. So the total charge for this one should be 6 minus. Plus 6 minus plus 6 minus, that will be 12 minus. So uh, the total charge here should be 12 minus, and we can rewrite it as in the this form: Si uh, O3 6 times, because Si is 6 numbers. So if we write like this, 6 into 1 be 6, and it's 18. So 3 into 6 is 18. So charge is 12 minus. So it's in the form of SiO3 3 into 2, and this is uh, 12 minus is 2 into uh, 6 minus. Oh, sorry, n is 6, so this should be 6. Sorry, 6, and on the top it's 2 into 6, that's 12. So also we can see that this one is SiO3 2 times 4 minus. So if we consider this is also in the form of SiO3 and 2N minus, but this cannot be a cyclosilicate because it's only 2 units are present. So for forming a cyclosilicate, there should be at least 3 units. So in this barai is the smallest cyclosilicate possible because it has the uh, for smaller cyclosilicate there should be um, 3 silicate unit. Uh, so smallest will be Si3O9 6 minus. Si3O9 6 minus is the smallest cyclosilicate and it's SiO. So there are 6 negative charges, 3 silicon and 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 oxygen. So this is the smallest cyclosilicate. And other silicates are orthosilicate, which is having formula SiO4 4 minus. And example is Mg or Fe twice SiO4. And another one is pyrosilicate, which has the form of Si2O7 2O7 6 minus. Another one is sheet silicate. It has uh, one aluminum replaced in Si4 O10 unit. So it has the example of K, Mg thrice, OH twice, Si3, Al, O10. So it should be Si4 O10 originally, but one silicon is replaced with one aluminum. And yeah, that's all for the first question. Next question is the basic unit of sheet silicate is option A Si3O9 6 minus, option B is Si2O7 6 minus, option C is Si2O5 2 minus, option D is Si4O11 6 minus. So in the previous question we have already seen this one, and sheet silicate is Si4 O10 unit or having Si4 O10 unit for sheet silicate, or else it can be SiO5 n times. So option C is the answer. The next question is the following statements are about silicates. A is cyclic silicate having 3 silicon atoms containing 6 SiO-Si linkages. B SiO3 n times 2n minus is the formula of cyclic chain silicate. C is Si4 4 minus unit polymerize to form silicate because Si atom has less tendency to form pi bonds with oxygen, and D is 2.5 oxygen atoms of per tetrahedron unit are shared in double chain silicate. So cyclic silicate having 3 Si atom containing 6 SiO Si linkages. So cyclic silicate having 3 Si atoms. 3 Si atoms. So for cyclic silicate, it is formula is SiO3 and 2N minus. So given 3 Si atoms. So it should be Si3O9 and 6 minus. We have to give n equal to 3. So Si3O9 is, we have already seen that in the first question. SiO, O, Si, Si, O, O, and O minus for 2 O minus on each silicon. So the statement is there is 6 SiO-Si linkages. So let's count. This is the first SiO-Si linkage, and next one is this one, 2, 1, 2, and third. So only 3 SiO-Si linkages are present. So this statement is wrong. Next one is SiO3 n times 2n minus is the formula of cyclic chain silicate. The statement is correct. And SiO4 4-minute units polymerized to form silicate because Si atom has less tendency to form pi bonds with oxygen. So the statement is again is true because silicon is in the third period while oxygen is in the second period. So the atomic orbital energies are different. So the formation of pi bond will be uh, less possible between silicon and oxygen. And the option D is 2.5 oxygen atoms of per tetrahedron units are shared in double chain silicate. So this is the double chain silicate, and uh, we can see that in bridging uh, Yeah, so if we look at this portion, we can see that uh, uh, one, and this is the second one, and half of this is uh, shared. So it's two and a half oxygen. So the answer is option D. The next question is treatment of hydrochloric acid with tin oxide gives. Option A is SnCl4 and H2O. Option B is SnCl5 minus and H3O plus. Option C is SnCl6 2 minus and H3O plus. And option D is SnOH 6 times 2 minus. Uh, so uh, tin oxide, so it is SnO2, and it's given a reactant with uh, hydrochloric acid. So it reacts with HCl. So when reacting with HCl, it will give SnCl6 2 minus and H3O plus. So balancing the equation, it will be 6 HCl and 2 H3O plus. And if we treat SnO2 with KOH and water, it will be giving SnO2 plus 2 KOH plus 2H2O. It will give K, K2SnOH 6 times. So the answer is option C, SnCl6 2 minus and H3O plus. And fifth question is PV3O4 on reaction with acetic acid results in. Option A, PbOAc 4 times and PbO2. Option B, PbOAc twice and PbO. Option C is PbOAc 4 times, and option D is PbOAc 4 times and PbOAc 2 times. And we can rewrite PbO4 as PbO and PbO2. So Pb3O4 is equivalent to PbO and PbO2. And PbO and PbO2 react with acetic acid differently, giving different products. So the reaction will be PbO2 plus 4CH3COOH will give PbOAc 4 times and 2 water, and 2 PbO reacting with 4 acetic acid will give 2 PbOAc twice and 2 water molecules. So total reaction will be, we can rewrite PbO2 and PbO as Pb3O4. So Pb3O4 plus, this will be 8 acetic acid. It will give 2 PbOAc twice plus PbOAc 4 times plus 4 H2. So the answer is option D, both PbOAc 4 times and PbOAc 2 times will be formed when PbO3 react with acetic acid. The next question is, all members of group 14 when heated in oxygen form oxides. The correct statement is option A, dioxide CO2, SiO2 and GeO2 are acidic, while SnO2 and PbO2 are amphoteric. Option B is CO, GeO, SnO, PbO are amphoteric, and C is monoxide react with hemoglobin to form toxic compounds, and option D is all oxides burn with blue flame. Uh, the first one is dioxide, CO2, SiO2 and GO2 are acidic, while SiO2 and PbO2 are amphoteric. So this statement is correct because we know that CO2 behaves as acid. Uh, and the second statement is CO, GO, SNO, PbO are amphoteric. No, the statement is wrong because they are uh, basic, because we know that CO can act as a ligand, and ligands are bases. So the statement is incorrect. And option C is monoxide react with hemoglobin to form toxic compounds. So the statement is incorrect because when carbon monoxide uh, get into the bloodstream, it bonds with ion of the hemoglobin, and it's not forming a toxic compound. Instead, the bond is strong, that so that the release of CO back will not be possible. So the O2 will not be able to bind to the ion for the oxygen transport. So the statement is wrong. And option D is all oxide burn with blue flame. So the statement is incorrect because CO2 will not be burned. It is formed after uh, a complete burning of organic materials. So the correct answer is option A. The next question is beryllium carbide react with water to give. Option A is BeO and acetylene. Option B is BeO2 and ethylene. Option C is BeO and methane. Option D is BeO and ethane. So uh, beryllium carbide is Be2C, which has the form Be double bond C double bond Be. So when it reacts with water, there is only one carbon. So organic compound with one carbon will be formed. Uh, uh, so Be2C plus 2H2O will be giving CH4 plus BeO. So the answer is option C, BeO and methane. Next question is, what is the charge on one nitrogen in N3 minus? So N3 minus is uh, like this. So for all three nitrogen, it's one negative charge. So for one nitrogen, it will be minus 1 by 3. So the option B is the correct answer. Next question is the example for ionic nitrides are option A Li3N and SON4. Option B is P3N5 and S2N2. Option C is Li3N and Mg3N2. Option D is P3N5 and Mg3N2. So ionic nitrides are first and second group nitrates. So like Li3N and M3N2, where M is second group elements, and there are uh, covalent in interstitial. Uh, nitrates. So example for covalent is boron nitrate, uh, cyanogen, uh, P3N5, S4N4, and S2N2. And interstitial are uh, there will be of the form Mn, M2N, or M4N, and M is D block elements. So here we are asked ionic nitride, so Li3N, and second group nitride. So the option C is the answer. Next question is complete the following chemical reaction with balanced equations. So first one is Sn plus XsI2. So it will be forming SnI4. Second one is Be2C plus H2. So we have already seen this one. So uh, it will give uh, 2BeO plus CH4. We'll need 2 water molecules. And CCl4 plus H2O, there will not be any reactions. Next one is Et2 SaCl2 plus LiAlH4. So it will replace this Cl2 with hydrogen. So it will be Et2 SiS2 plus LiAlH2Cl2. The next question is write down the reaction of phosgene. So phosgene is C double bond of ClCl, which is Cl2CO or COCl2. So first COCl2 is formed from direct reaction of CO plus Cl2. It gives COCl2. So the reactions are uh, so it reacts with the alcohols to form then reaction with water, so it forms CO2. It reacts with NH3 to form urea. Then it reacts with RNH2. R will form Rn double bond C double bond O, and react with R2NH. So it will form R2NCO Cl, and react with SPF3, and then Cl2 forms replaces chlorine with fluorine. Next one is write down the reactions of CH3X, where X is the halogen. So CH3X, and when it reacts with zinc, it will form CH3 ZnCl and when it reacts with magnesium, it forms Grignard reagent, which is CH3 MgBr. Then react with the cobalt cyanide complex, and when it is excess iodine, uh, the products are COCl 5 times 3 minutes, and when it reacts with iridium complex, IrL2 ClCO, it forms a six coordinated complex, IR CO and X, and react with where when X equal to add it, the next question is the number of SiO-Si linkages present in the basic units of cyclosilicate. One Si3O9X 6 minus, and second one is Si6O18 12 minus R. Option A is 1, 4 and 2, B is 3 and 4, C is 3 and 6, and D is 4 and 6. Uh, these are the basic unit like uh, Si3O9 6 minus, yes, and this one is for Si6O18 12 minus. So we are asked to find number of SiO-Si linkages. So here it's SiO-Si is 1, 2, and 3. So for uh, Si3O9 6 minus, it's 3, and for Si6O18 we have to find uh, this one is oxygen. So inside each tetrahedral unit there are uh, one silicon in each one. So here it will be one Si. Again here again in each tetrahedron there will be one silicon uh, inside. So if we count Si, so this one is 1, this one is 2, This one is 3. This one is 4. This one is 5 and 6. So there are 6 SiO linkage in Si6 O18 12 minus. So option C is the answer. Next question is biotech KMgFe thrice AlSi 3 times O10 OS2 is an example of option A sheet silicate, option B single chain silicate, option C orthosilicate, and option D cyclosilicate. So in sheet silicate, one of the Si will be replaced with aluminum in Si4 O10 unit. So that's what we have to remember. In sheet silicate, there will be one aluminum replacing uh, one silicon in Si4 O10 unit. So there was if we replace Al by Si, then it's Si4 O10. So one aluminum is replaced from Si4 O10. So it's a sheet silicate. Next question is the structure of compounds GeO2 and SnO2 adopt. Option A zinc blende structure. Option B is rock salt structure. Option C is woodside structure. And option D is rutile structure. So zinc blende is ZnS. Rock salt is having NaCl structure. Woodside is ZnO. And rutile is TiO2. So in zinc blende structure, uh, all the sulfur will be in FCC and zinc will be present in the alternate tetrahedral voids. In rock salt structure, both sodium and chloride, sodium ion and chloride ion crystallizes in FCC, but uh, chloride ion will be present in the corners and base centers, and sodium ion will be present in the body center and edge centers. In woodside, it will be in hexagonal lattice HCP, and so GeO2 and SnO2 adopts rutile structure of TiO2. Uh, Next question is the treatment of phosgene with uh, R2NH and RNH2 results in option A R2N double bond CO, second RCl and ClCO. Option B is R2N ClCO and RCl and ClCO. Option C is R2N double bond CO and RCl and double bond CO. And option D is R2N ClCO and Rn double bond CO. So we have already discussed the reaction of phosgene. So when Cl Cl react with R2NH, it gives R2N C double bond O Cl and C double bond O Cl react with RNH2 gives Rn double bond C double bond O. So in each reaction, what happens is that the H will be removing chlorine. So here only one H is present. So it removes one HCl by removing a Cl from here, and here there are two H present, so it removes both Cl. So the answer is option D. Next question is the reaction of Et2SiCl2 with LiAlH4 gives. Option A is EtSiH3 plus LiAlH2Cl2. Option B is Et2SiH2 plus LiAlH2Cl2. Option C is EtSiH3 plus LiAlHCl3. And option D is Et2SiH2 plus LiAlH3Cl. So, when Et2SiCl2 react with LiAlH4, it replaces both Cl2. So, Et2SiCl2 plus LiAlH4 hydrogenate and replaces Cl with hydrogen. So, it gives Et2SiH2 plus LiAlH2Cl2. So, option B is the answer. Next question is oxidation of P4 by concentrated HNO3 gives. Option A is 3PO2 and NO2, N2O and S2O. Option B is S3PO3 NO and S2O. Option C is S3PO4 NO2 S2O. Option D is H4P2O5 N2O4 and S2. So P4 when react with 20 HNO3, it will form S3PO4 NO2 and water. If it was reacting with sodium hydroxide, it will be P4 3 NaOH plus in water it will form PS3 phosphine. So the question was P4 reaction with HNO3 gives H3PO4 NO2 and S2O. So option C is the answer. The next question is the reaction of N2FASF6 with HN3 in anhydrous HF solvent gives. Option A is ASF3, B N5ASF4, C N5ASF6, and option D ASF5. So N2FASF6 is rewritten as N2F in ASF6. Plus HN3 will give N5 ASF6 plus HF. So the answer is option C. The next question is the number of POP linkages present in the structure of P4O10 is or are. Option A is 2, B is 4, C is 6 and D is 8. So P4O10 it's synthesized from P4 and heated at 323 Kelvin in presence of oxygen, it gives P4O10. And structure is 4P connected with oxygen, and all of the P are connected through oxygen to each other. So number of P of P linkages. So this one is 1. Also double bond O is present. The total is P4O10. So uh, this one POP, the second one, third POP bridge, and fourth one, this is the fifth one, and POP, this is the sixth one. So option C is the answer. Next question is the reaction of SnI4 with KNH2 in liquid ammonia give at 243 Kelvin gives option A SnNH2 4 times, option B SnNH twice, option C SN3N4, and option D SN2N4. So this is the process to synthesize uh, nitride of tin. So SnI4 plus KNH2 243 Kelvin in liquid ammonia SN3 and 4. So option C is the answer. So that's all for today. Thank you. We'll see